is formula is dy over dx. There is only a very minor change into the formula of the backward and the forward, and you will observe that let me write down first and then we shall discuss the differences. So the first formula is whenever we one time differentiate, we get 1 over h times nebula yn plus 2p plus 1 over 2 factorial into nebula 2yn plus 3p square plus 6p plus 2 whole divided by 3 factorial and nebula 3yn and so on. Now if you look at this formula and the formula for the forward difference interpolation, there are few changes, and one of the changes, we have used the nebula operator everywhere, while there we have used the forward difference operator in the form of delta. And second change is, everywhere there was minus sign, you have observed, I have replaced them with the plus sign. And you can see here, nothing else is any difference there. And the other difference you can observe is yn. There we have used y0. So these are the few changes which we are doing to create the backward difference formulas. So you can do it of yourself. First change is change the operator from forward difference to backward difference, yn to y0 to yn, and where there are minus sign or only the minus sign into the forward difference formula, just replace them with the plus sign. So these are the changes you have to make to create 6 more formulas for the backward difference interpolation. And whenever you differentiate it once again, second order formula is d2y over dx square can be obtained by writing 1 over h square nebula 2yn plus 6p plus 6 over 3 factorial nebula 3y. Okay, so this is the second order derivatives formula for the backward, and here we write down the third order derivatives formula d3y over dx cube is equals to 1 over h cube. Inside this is nebula 3yn plus 1 by 2 times 2p plus 3 times nebula 4yn, and there can be many more terms you can write down. So these are the 3 formulas, 1, 2 and 3 for the backward difference interpolation. And similarly, we can also write down 3 more formulas for the case whenever p gets 0. So on putting p equals to 0 over here, all the terms with p will be getting 0. So the first dy over dx will take the form 1 over h times nebula yn. From here, this p gets 0, 1 over 2 factorial into nebula square yn. Over here, this gives you 2 over 6, so 1 by 3 nebula 3yn and so on. So this becomes your first formula for the case whenever p is equals to 0. Similarly, d2 y over dp square, from here, dx square, this is equals to 1 over h square. 1 over h square is there. Inside this is nebula 2yn, and from here 6 over 6 gives you 1. So the result is nebula 3yn plus, over here 11 by 12, and this nebula 4yn, and then the result is, this is n here, not 0, and so on. So this becomes your second derivatives formula when p is equals to 0. Similarly, if I make a change directly here, whenever p is equals to 0, so this term will be there will be no more term like this, and everywhere there will be 0. So not 0, accordingly you have to make the change. So the result is 3 by 2. So these are the collectively 6 formulas for the case of the backward, and there were 6 formulas for the forward. So collectively these are the 12 formulas, and you have to use according to the requirement of the question. Now at the end, we try to use these formulas or one of these formulas for a simple question. So here we start solving a question. Okay, so the statement of the question is, okay, you are provided data in the form of the 2 quantities, these are years and the population. So in 1951, 1961, 1971, 81, and 1991. So these are the 5 years plan, and during these 5 years the population of a town is 19.96 during 1951, 36.65, 58.81, 77.21, and 94.61. These are the different populations during the different periods. And now we have to find out the rate of change of this population in the year 1981. Okay, this is the place where we have to measure the change. So if we label these 2 quantities with X and Y, so it will be rather easy for us to call them as X and Y instead of years and population. So X is equals to 1981. You have to find dy over dx during this year when X equals to 1981. So in order to find out dy over dx, or the rate of change in the year 1981, so first of all we have to calculate P. So the formulas for the P is, because we are looking at a value close to the end point, so here we have to use a backward formula. So I am putting here x minus xn instead of x minus x0. On putting the values, x is 1981 and xn is 1991 over each is a period of 10. So on putting this and solving this, we get the result is equals to -1. Okay, now after knowing these, the next step is to construct the difference table so that we could use the differences involved in the formula. So here we construct the difference table. The values of x, y, these are the years and population. Next we have to calculate nebula yn, nebula 2 yn. There are 5 years planned. We can move up to the 4th order difference. So the next will be nebula 3yn, and last will be nebula 4y. Okay. And now fill these. The values of x are 1951, 61, 71, 81, and 1991. And the populations are 36, 65, 58, 81, 77.21, and I missed. Sorry, the first value is 19, 96, 36.65, 58.81, 77.21, and 94.61. And the corresponding differences you can obtain by using the same principle. So the first difference is 16.69, 22.16, 18.4, and 17.4. The next order differences can be obtained on the same pattern: 5.47, minus 3.76, and minus 1. Keep on moving, it gives you minus 9.23 and 2.76, and the last is 11.99. So here you can see we construct the difference table, and because we are using the backward, so we have to highlight the values. We take start from here, the values which we can use, I put them into the box. So after writing these, let's write them separately to make the idea clear how actually it works on. Here yn is 94.61, nebula yn is 17.4, and nebula 2yn is -1. This is nebula 2yn, and this is nebula 4yn, and nebula 3ayn is equals to 2.76, and the last one, nebula 5yn, is 11.99. So these are the differences we have to use into the formula. So we already know the formula for the rate of change in the backward case is 1 over h times nebula yn plus 2p plus 1 over 2 times nebula 2 yn 3p square plus 6p plus 2 whole divided by 6 nebula 3yn, and one more difference I have to use, that's why I'm erasing it from here. Okay, and the fifth difference can be written in the form of 2p cube plus 9p square plus 11p plus 3 whole divided by 12 into nebula 4 yn, and so on. So this is the formula we have to make use. Now we have all the values. P was equals to, if you remember, P was equals to -1, and all the differences are there. We have to use them into the formula. Now put the values into this. We get 1 over 10 outside the inside delta yn is 17.4 plus 2 into p, -1 plus 1 over 2, nebula 2 is -1 plus 3 into -1 square plus 6 into -1 plus 2 whole divided by 6, and 2.76 plus 2 into -1 whole cube, -1 square over here, and then 11 into -1 plus 3 whole divided by 12 into delta 4. Delta 4 is 11.99. So I have substituted all the values into the formula. Remaining you can use your calculating devices, and the result is equals to 1.64 almost. So this is the rate of change or rate of growth of the population in the year of 1981. So collectively, if you summarize the whole article, so we generally constructed the 6 formulas for the numerical differentiation, 12 formulas collectively, 6 for the forward and 6 for the backward. I hope you have learned all the things which I have expressed here, and if you still have any queries or questions in your mind, you can share your results, and you can share your questions with me through different sources. So with this, thank you very much. So.